Alright, we're back with another Practice Exam 2 segment. This is problem number 9 for Physics 212. The question asks, find the time constant for the RC circuit in the figure in terms of R1, R2, C1, and C2. So as you can see here we have R1, R2, C1, and C2. We're looking for tau. Now, this is given a voltage right here. It's given a voltage of, I believe, 10 volts. This voltage source. Voltage actually has no effect on the time constant value. The time constant value will change how a voltage would charge or discharge, but even if there was no voltage source here, this circuit here would still have a tau constant. It just wouldn't be working because there would be no charging or discharging. But the tau constant is intrinsic to the resistors and capacitors of a circuit. It has nothing to do with the voltage source. So that's kind of throwing you for a loop there maybe. We know that tau is equal to resistance times capacitance. That's in ohms and farads. And so essentially what we have here is just simplifying a circuit. So what we want to get really is I'm going to draw the voltage source this way. We want to collapse the two resistors into an equivalent resistor that I'm going to call R12 because it's collapsing R1 and R2 together, and some equivalent capacitance to these two capacitors. I'll call it C12. And the trick here is that resistors in parallel and capacitors in parallel are added in inverse ways. So to find R12, we'll have to say that 1 over R12 equals 1 over R1 plus 1 over R2. And conversely, for capacitance 1,2, in parallel we add capacitance in a summation form with no inverse. And so that means that C12 is simply going to be C1 plus C2. Alright, so if we did know R12 and C12, then tau for the circuit would equal R12 times C12, or the equivalent resistor and equivalent capacitor in the circuit. And now that we've solved for those in terms of C1 and C2, I'm going to go ahead and, well, let's solve for R12 first. Okay, so we could multiply R12 over on both sides. R12, we multiplied it over, so it leaves from this side. And then let's divide by 1 over R1 plus 1 over R2. And so what we end up with is R12 equals 1 over R1 plus 1 over R2. And that's pretty much good enough for me. There is a way to simplify it further, but it didn't tell you to simplify it. It just said find the time constant in terms of R1, R2, and C1, C2. So tau is going to equal R12, the equivalent resistor, C12, the equivalent capacitor, and so what we end up with is tau is equal to 1 over R1 plus 1 over R2 times C1 plus C2. And don't forget the brackets. We need to make sure that the order of operations is maintained. So there is the form you can use. I'm trying to remember how to simplify this, but really it's not important to the problem, so hopefully this was helpful.